So we looked at arrays, and we saw how we define an array, we access the elements of an array, and now we will look at manipulating an array. So in order to look at the manipulation of an array, we will look at two examples. So manipulation involves two things. One, where we sequentially access. That is, first example will be sequentially access an array. And the second example will involve accessing till success. And I'll explain what these are. What we will also learn in this module is how to pass an array to a subroutine. So the first problem we're going to look at is to find the max score in an array of student scores. And the idea is that we will write a subroutine. So the subroutine is going to be called max, and it will take as input an array. This is an array of students in a class. I'm going to call that class. And a second parameter, which will be the size. So the idea is that the array when called, the subroutine when called, will be passed an array of some length, but since we don't know what the length is by looking at this parameter, we pass a second parameter, which is the size of the array. As a result of running this subroutine, it will find the maximum element and return the maximum element back to the caller. So the way we pass an array to a subroutine then is by specifying the name of the subroutine, but we do not specify the length of the array. This way we can make the subroutine very generic so that we could have an array. For example, this could be a class of students with let's say this is an array of 50 students indexed from 0 to, let's say, 49. So there's 50 students here. Now I can find the maximum of all 50 students, or I could only find the maximum of the first 20 students. I can make this subroutine general so that I can pass the size as that term by which I want to limit the search for the maximum to. So let's write the subroutine then. So I'm going to declare a local variable. I call it the largest, which is going to hold at any time the largest value so far, and I'm going to use an index I. So this is a case of using a for loop, and the idea is that anytime we know we have to reach all of the elements, so in order to find the maximum element out of n elements, whatever this n is, here the n is size, I have to touch every element to find out which one is the max. So the natural fit is a for loop. So I say for, I start from the beginning, I is equal to 0. I go all the way till the end, which means I is less than size. And remember that if the size is let's say 5, then I have to look at elements 0, 1, 2, 3, 4. So it's always less than the size that I have to go up to. And then I have I++. So we saw this in the previous video. We have the initialization, we have the condition to stop, and the update step. And now I'm going to look at each item. So if I say if class of I, the item that the score that I'm currently looking at, the ith score, if this is greater than the largest, then I have to set this item to be the new largest. So I say largest equals class of I. Now if this is not the new largest, if it's not the new largest, then I don't worry about it. So I go off and pick the next element. So this way, as I iterate through this, I touch the first element. Let's say my array that has been passed to me, so this is class, and let's say size was equal to 50. So size is 50, and I start from I. So I is initially equal to 0. That's what that says. I compare against the first element. Let's say the first score was 15, the second score was 30, the third score was 21, and so on, all the way up to the last score, which was, let's say, another 17. So I'm gonna look at each item, and anytime I find an item that's larger than the largest so far, I will swap it. But the only problem in this code is that the largest, which was declared here, has not been initialized. If you don't initialize a variable, you can't assume that it's going to be equal to 0. So I'm going to do an explicit initialization. I say largest equal to 0. So when I haven't touched any item yet, the largest item has a value of 0. So once I'm out of this for loop, I have the largest in the variable largest, so I simply return it. So that is the end of my subroutine. So this is an example where we see sequential access, which means that we access the first item, the second item, the third item, and so on, all the way up to the last item. And we also saw that we are passing a sub-array to a subroutine. We pass it by not specifying no size in the array that we pass, but we pass a second parameter. Second parameter has the size. So this, for sequential access, the for loop is a natural fit. So in the next video, we'll take a look at arrays that are manipulated using this second paradigm, which is access till success.